For most of human history, we believed the solar system was complete. Finished, mapped, under control, 9 planets, clear orbits, simple rules, a cosmic order that felt permanent, almost comforting. We taught it in classrooms. We printed it in textbooks. We grew up believing that this was the final version of our neighborhood in space. And then, without warning, that certainty collapsed. Not because of an explosion, not because of a dramatic announcement, but because of a quiet discovery made in the darkest outskirts of the solar system. A discovery so disruptive that it didn't just add something new, it erased something old. Most people believe Pluto was demoted because scientists changed their minds. That explanation sounds harmless, almost casual, but it's not true. Pluto wasn't removed because opinions change. Pluto was removed because the rules stopped working. And when rules stop working in science, something is deeply wrong. It started with a faint moving point of light, detected far beyond Neptune, in a region where sunlight is weak and objects move painfully slow. At first, astronomers thought it was just another icy body, one more piece of debris left over from the formation of the solar system. But as the data improved, discomfort set in. Because this object wasn't small, it wasn't insignificant, and it wasn't easy to ignore. It was massive, comparable in size to Pluto, and in some measurements, even heavier. That single fact triggered a crisis that no one was prepared for. Because if Pluto was a planet, then this object had to be one too. And if this was a planet, how many more were out there? Suddenly, the solar system wasn't a clean list of 9 worlds anymore. It was becoming crowded, messy, unpredictable. Astronomers realized they were standing at the edge of a problem with no comfortable solution. Either they would have to accept that the solar system contained dozens of planets, or they would have to redefine what the word planet even meant. That choice would change everything. For decades, Pluto had been treated as a special case, a lonely outlier, an exception to the rule. But this discovery destroyed that illusion completely. Pluto wasn't unique, it wasn't special, it was part of a population. And once that became clear, the foundation cracked. Because science doesn't run on emotion or nostalgia. It runs on classification, and classification demands consistency. As the debate intensified, one uncomfortable realization kept resurfacing. The old definition of a planet was never precise. It was informal, vague, based more on tradition than strict criteria. That worked fine, until it didn't. The moment astronomers acknowledged that Pluto shared its region of space with countless other icy bodies, everything changed. Pluto had not cleared its orbit. Neither had the newly discovered object. And that detail became the turning point. In 2006, astronomers gathered to make a decision that would ripple far beyond the scientific community. They weren't just voting on a definition. They were deciding how humanity would describe its place in the universe. The result shocked the public. Pluto was no longer classified as a planet. Overnight, something that had been part of human knowledge for generations lost its status. No explosion, no movement, no physical change, just a reclassification. And most people never stopped to ask the deeper question. What was so threatening about this discovery that scientists chose to redraw the rules instead of expanding them? The object responsible for this upheaval was eventually named Eris, after the Greek goddess of chaos and discord. And the name could not have been more accurate. Because Eris did exactly what chaos does best. It exposed weaknesses, forced conflict, and shattered assumptions we didn't even realize we were relying on. Eris orbits the Sun at an extreme distance, far beyond Pluto, in a region filled with frozen remnants from the birth of the solar system. This is not a gentle environment. Temperatures are near absolute zero. Sunlight is barely present. For centuries, humanity assumed this region was quiet, inactive, almost irrelevant. Eris proved otherwise, because its existence alone meant that the solar system was far larger and far more complex than we had admitted. And if one such object existed, there was no logical reason to believe it was alone. That realization didn't bring clarity. It brought fear. Fear of losing control over a system we thought we understood. Fear of admitting that the neat diagram in our minds was wrong. Fear of opening the door to questions we couldn't yet answer. And once that door was opened, it could never be closed again. Loop pause, because if Eris changed the definition of a planet, what else might it change next? Eris didn't just challenge Pluto. It challenged how science reacts when reality doesn't cooperate. To solve the problem, astronomers created a new category: dwarf planets. Objects large enough to be round, massive enough to matter, but unable to dominate their orbital neighborhood. Pluto was placed there. Eris followed. On paper, the crisis was resolved. In reality, the debate was only beginning. Because the definition itself was created after Eris was discovered, not before. Which meant the rules were rewritten in response to an inconvenience. That detail still unsettles many scientists. Some argue the new definition saved astronomy from chaos. Others believe Pluto was unfairly stripped of its status. And some quietly admit that the vote which decided this issue involved only a small fraction of eligible astronomers worldwide. A decision that reshaped humanity's view of the solar system, made by surprisingly few people. That alone raises uncomfortable questions. If scientific definitions can change this dramatically, how stable is our understanding of anything? Eris continues its slow, silent orbit, taking more than 5 centuries to circle the Sun once. When it was discovered, it was near the farthest point in its orbit, cold, dark, and difficult to detect. That fact leads to another unsettling realization. If humanity could detect Eris at its most distant and least visible state, what else have we missed? Since Eris, astronomers have identified dozens of large objects beyond Neptune. Some nearly Pluto-sized, some with moons, some with orbits tilted at strange angles, as if something massive disturbed them long ago. Each discovery reinforces the same message: the solar system is not finished. It is not static, it is not neatly organized, and it is not fully understood. Even today, Eris reflects an unusually high amount of light, suggesting fresh ice on its surface. That hints at processes still active in a region we once assumed was frozen and dead. How many other distant worlds are quietly evolving beyond our reach? Pluto, once dismissed, later shocked scientists when a spacecraft revealed mountains, glaciers, and signs of geological activity. It looked alive. That revelation only deepened the controversy. If Pluto can be active, why not Eris? Why not others even farther out? The discovery of Eris forced scientists to confront a truth that extends far beyond planetary labels. Science does not lead reality. It follows it, and when reality refuses to fit into our definitions, the definitions must change, even if that change is uncomfortable. The solar system we imagine is a simplified story. The real one is dynamic, chaotic, and still revealing its secrets. Some researchers believe even larger objects may exist far beyond Eris. Worlds with orbits so long that humanity has never observed a full revolution. Objects whose gravitational influence may already be shaping the outer solar system in subtle, unseen ways. Once Eris was discovered, the idea of hidden worlds stopped sounding like science fiction. It became a logical expectation. Because Eris taught us something fundamental. The universe does not care about our categories. It does not care about tradition. And it does not care how uncomfortable a discovery makes us feel. It simply exists, and every time we think we have it figured out, something in the darkness reminds us that we don't. Eris will continue its slow journey for centuries, long after current debates fade, long after new definitions replace old ones. But its impact is permanent, because once the rules are broken, they can never feel absolute again. And somewhere beyond Neptune, chaos still circles the Sun, silently, patiently, waiting for the next discovery that will force humanity to rewrite its understanding of the universe one more time.